Hello friends, how are you all today? Have you ever wondered what are random variables and how they can be used in engineering? It's coming up right now. I'm Prashant from Dharini Academy of Technical Education, Bengaluru. We'll be discussing about random variables now.
In the previous class, we were looking at solving the problems of continuous distributions, correct? Now, let's proceed with the similar one because we solved on finding the mean, variance, etc. Right? Okay. Now, let's go to another problem based on same. If f of x is equal to this is k x into e to the minus x from 0 less than or equal to x less than or equal to 1 is a valid PDF, then find its mean and probability that 0.25 less than or equal to x less than or equal to 0.75. So this is the question. Let's try to solve this. So initially we apply that is integral 0 to 1 kx e to the minus x dx should be equal to 1. So when you solve it, you get the value of k, right? Okay, so the k value comes to be equal to 0.736. Now apply this, and we are supposed to find out the mean first, and then we are supposed to find out the probability which is asked. Okay, so what is the equation to find mean? Mu is equal to this is 0 to 1. The value of the function, that is k value, 0.736 times x into x into f of x. So f of x has another x, right? So this becomes x squared, right? So x into f of x has an x, so this becomes x squared into e to the minus x dx. Okay, so we solve this to get the answer. So the mean comes to be equal to 0.194. Right, very similar to this. Now we need to find out the probability, right? So that is P of 0.25 less than or equal to x less than or equal to 0.75 should be equal to right. This is integral 0.25 to 0.75 0.736 x e to the minus x dx. And that value comes to be equal to 0.108. Yes, that's the first problem. Okay, then we try to relate this to the CDF in the next problem. Okay, so find the CDF of the following PDFs. So it means whatever has been mentioned here is a PDF. Okay, so yeah, we want a cumulative, correct? So this is 6x minus 6x squared, 0 less than or equal to x less than equal to 1, 0 else. So that's the first one. All right, let's solve this. Then we'll go for the next one. And now we know that the f of x CDF is equal to probability that the random variable x, capital X, takes all the values less than or equal to a specific value x. So that is equal to minus infinity till x. Okay, from minus infinity till x, take the f of x dx. No, that it has to be integrated, correct? So this means it is integration minus infinity till x, right? Substitute this value, that is f of x is nothing but this. Okay, I cannot put this limit because you see that there is a 0 else, so I just have to integrate 0 to x. Okay, in this case it is only that. So 0 to x, this is 6x minus 6x squared dx. Just have to integrate to get a single answer at the end. So we get answer 3x squared minus 4x cubed. That integration final answer is 3x squared minus 2x cubed. All right, okay, let's go to the next one. This is f of x is equal to x by 4 e to the minus x by 2, 0 less than or equal to x less than or equal to infinity. Okay, this is the question. It is 0 else. So capital F of x is equal to, it is 0 to x into given function, and I'll take the 1 by 4 outside. This is x into e to the minus of x by 2 dx. This is a product, correct? So has to x into e to the power minus x by 2 is a product. UV rule should be applied, right? Otherwise we may not get an answer because, right, it's a product. UV rule needs to be applied. So when we substitute these limits, we are going to get, this is say 1 by 4 times the minus half in the denominator goes to numerator as minus 2. Okay, this is minus 2 into, so substitution of x remains as it is. This is x into e to the minus x by 2, and when you put 0, this becomes whole function is 0, correct? Then I have a minus, the 1 by 4 goes to numerator as a 4, right? Then I'm going to substitute x equal to x itself, that is e to the minus x by 2. When you put 0 to that, it becomes 1, right? So this is minus 1. Okay, so now after simplification, so 4 cancels with 4. I'll write the 1 first because that's a positive term here. That is minus 4 into this divided by 4. All right, so that's a 1 here. Then I have 2 cancelling with the 4. Okay, 4 cancelling with 4. It's a minus e to the minus x by 2. Then I have minus, this is x, 2 cancelling with 4 as 2, minus x by 2 e to the minus x by 2. I think this is the answer. Just verify once. This is the next question. If a random variable has the PDF f of x is equal to k by 1 plus x squared, 0 less than or equal to, okay, let me give the limits changed, minus infinity less than or equal to x, less than or equal to plus infinity. So the limit is minus infinity to plus infinity, right? Find k, probability x less than or equal to 2, then probability that x greater than or equal to 0, probability 0 less than or equal to x less than or equal to 1. All right, so this is the next question. So in order to find k, we have to apply the basic rule, that is integral minus infinity to infinity f of x dx equals to 1, right? This implies it is same integral minus infinity to plus infinity. This is k divided by 1 plus x squared dx equal to 1. All right, fine. So I can write k into pi by 2 minus pi by 2, correct? So this is plus pi by 2 equals to, this is equal to 1. So this means how much? K is equal to, yeah, this is 0.318. Now we have to use this value of k to find p of x less than or equal to 2, right? Should be calculated as, this is integral minus infinity till 2, right, f of x dx. F of x is, there is a 1 by pi, that is 0.318 divided by, this is 1 plus x squared dx. Repeat this answer, 0.851. All right, let's go to the next part. This says that p of x greater than 0, right? And when equal to 0 means this has to be 0 to infinity, 0.318 by 1 plus x squared dx. Okay, this is equal to 0.499. All right, then we have another part, 0 to 1. Okay, so probability that 0 less than or equal to x less than or equal to 1, this is integral 0 to 1, 0.3185 1 plus x squared dx. Okay, so this value comes to be 0.249, right? Okay, I think that's a right answer.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.